Homework 3.2 Polynomial Functions, Video 5. Homework due Wednesday, May 27, 2020 at 11:59 p.m. The following video directly associates with questions 8 and 9 in the homework, and it's part of questions 10, 11, and 12. In the previous video, we talked about finding x-intercepts, multiplicities, and x-axis x-axis behavior, whether you cross the x-axis or you touch and turn around. But those functions were all factored, which made solving them equal to 0 easy. But none of these are factored. And you may recognize these four functions as the same four functions from the second video when we discussed in behavior. So how do you do this when it's not factored? The answer is you have to factor it. You still find x-intercepts the same way. You still put the function equal to 0, x to the third plus 5x squared minus 4x minus 20 equal to 0. But now in order to solve it, you have to factor it, which means you have to have an arsenal of factoring techniques at your disposal. Greatest common factor, grouping, factoring trinomials, factoring difference of squares, those will be the main ones. If your factoring skills are still a little bit shaky, I strongly recommend going to Module 2 between the first and second homework assignments and watching the videos that are reviewing factoring, because I'm going to be using all of those techniques now. All right, so if we wanted to solve this one, when you're factoring, the first thing you should always ask yourself is there a greatest common factor besides 1? In this case, the answer is no. Your next move is basically dictated by how many terms it has. If your polynomial has 4 terms, that means you should try a grouping problem. And grouping is just splitting this into 2 groups and doing the GCF on each half. For example, x to the third plus 5x squared, I can factor out an x squared, and that would leave an x plus 5. For the second group's GCF, I can factor out a 4, but part of the grouping process is knowing that the middle sign right after the split belongs to the second GCF. So I would actually factor out a -4, and if I did that carefully, I would still get x plus 5. Grouping works on the premise that these match. If they don't, it means one of 2 things. 1, you made a mistake, see if you can fix it. Or 2, it's not a grouping problem. 4 terms means it might be a grouping problem, but it's not a guarantee. If these didn't match, we couldn't factor it this way. We'll learn a new way to factor in videos right around the corner. But for now, if the parentheses match, then they become the GCF and get pulled out in front. And everything else, the x squared and the -4, becomes the other factor. And suddenly we're factored. Now we're not factored completely. Here's x squared minus 4 again. It made an appearance in the previous video. So the x plus 5 is done, but the x squared minus 4, being a difference of squares, would factor into x minus 2 and x plus 2 in no particular order. So if we put each factor equal to 0 and solve, we get x equals -5, x equals 2, and x equals -2. Each of these came from a parentheses with no power, so the implied power is 1, which means for every one of these, the multiplicity equals 1. So what does that mean about crossing the x-axis versus touching and turning? I know it was up here in the previous video, but I needed the space. If the multiplicity is odd, that means the graph will cross the x-axis. So cross, cross, cross. I invite you to pause the video and try to find the intercepts, multiplicities, and x-axis behavior for the remaining 3 polynomial functions. I will tell you right now that the rest of them all start out with the GCF, but then may or may not do different things. I'm going to go ahead and continue. Pause the video if you want to try it now. For B, we would put x to the 4th minus 9x squared equal to 0. And when you're factoring, you should always ask yourself, is there a greatest common factor? There is on this one. These both have an x squared that I can factor out. And so the terms would each go down by 2 x's. So the x to the 4th would go down to x squared, and the minus 9x squared would lose both of its x's and just leave a minus 9. Oh, look, it's another difference of squares. So the x minus 9 factors into x minus 3 and x plus 3. And now we can put each factor equal to 0 and solve. Remember what I said in the previous video, if a factor is a monomial, one term, and it contains an x, then putting it equal to 0 will always give you x equals 0. The other two x-intercepts are x equals positive 3 and x equals negative 3, but their multiplicities aren't all the same. Which one has a multiplicity that's different from the others? The 0. Why? Because the multiplicity is the power that was on the factor that gave you the x-intercept. This x equals 0 came from x squared, which means its multiplicity is 2. The other two, having no written powers, are implied powers of 1. So their multiplicities are 1. And as before, if your multiplicity is odd, you cross. So this graph would cross at x equals 3, and it would cross at x equals negative 3. But this x-intercept's multiplicity was even, which means this graph would touch the x-axis at x equals 0 and then turn around. I invite you to go back to the second video and look at the 4 graphs that I had drawn already. They do these things. We'll draw some of them in future videos. What about C? H of x equals negative x to the 5th plus x to the 3rd. Well, not to sound like a broken record, but we do the same thing. We just get different results. First move, is there a GCF? And the answer is yes. All of these have x's, and they all have 3 x's in common. But here's a little story about GCFs. If your leading term is negative, your GCF should also be negative. Why? Because then in here, it'll start out with a positive. So on both of these, I'm going to factor out 3 of the x's, and I'm going to factor out a negative, which will change their signs. So this first term will become positive and lose 3 of its x's, having 2 of them left, so x squared. The second term will be negative, and I take out 3 of its x's. Wait, that's all it has. What's left here? Well, what's in front of the x cubed? You can't see it, but it's a 1. Redistribute if you want to make sure it's factored correctly. Oh, look, another difference of squares. So negative x to the 3rd, x minus 1, x plus 1. I made a different function earlier, but we'll go with this one. All right, so hey, here's another factor that's a monomial with an x, so it gives us x equals 0, and the other two x-intercepts are x equals 1 and x equals negative 1. But notice that all of these multiplicities are odd. The multiplicity of the 0 is 3, so multiplicity equals 3, and each of these has a multiplicity of 1. Typically a multiplicity is 1, because usually a power and a factor is 1. It doesn't have to be, but it just usually is. So because all these multiplicities are odd, this graph will cross, cross, and cross the x-axis at 0, 1, and negative 1. For this last one, if we solve negative x to the 4th plus 6x to the 3rd minus 9x squared equals 0, there is a greatest common factor. Everybody has an x squared embedded inside of it, but just like the previous example, because the leading term is negative, when I factor out my GCF, I'm going to factor out the negative with it. I've just learned from experience that factoring things is better when they don't have a negative in front of them. So pull the negative off so it's not in the front anymore. So everybody's x count is going down by 2, and everybody's sign is going to change. That should leave us x to the 2nd minus 6x plus 9, and now we have a trinomial to factor. To factor this, I would need 2 numbers that add to give negative 6, but multiply to give positive 9. How about negative 3 and negative 3? Yeah, but wait, these match. Why am I writing them twice when I can just write it once and put a square on it? And that's important in order to correctly identify its multiplicity. Our x-intercepts are 0 and 3, but both multiplicities are 2. And because both multiplicities are even, that means that at each x-intercept it will touch and turn. Touch and turn. In video 3 at the beginning when I said I had drawn a graph incorrectly, go back and compare what it used to look like versus what it looked like when I corrected it. It was this one. I had the wrong x-intercept in my mind previously. I thought it was -3, which is why it was over to the left. All right, so finding x-intercepts for unfactored polynomials means that you better get to factoring. Now, in the homework, anything that requires factoring will be factorable, but it does raise a question, what if I give you a 4-term polynomial and it doesn't factor by grouping? In other words, how do you factor something that isn't conveniently factorable? The answer to that lies in the next homeworks, 3.3 and 3.4, so we'll cross that bridge soon.